So today our topic is vector space and subspaces. We will try to dive deep into the concept. For this, I assume that we are aware about vectors and all. If we have taken physics class 11, 12, then this would be easy for us to understand. So first of all, the question arises, what is vector space? So at heart, a vector space, a vector space is a collection of objects or vectors. Remember, and collection of vectors together with two operations which are addition, because as we know, if we add two vectors, the result is still a vector in the same set. So addition of two vectors, you can say two or more vectors, results in a vector present in same set, present in same set. Second thing is scalar multiplication. Scalar multiplication. Scalar multiplication. So you can multiply a vector by a number. Scalar. Okay, so scalar is something that is just a value. So for example, if you have a vector that has a direction and magnitude and we multiply it by a scalar, multiply it by a scalar, like a scalar. The result result is a vector in same set. So the question that must be in your mind is, first of all, why only two operations? Also, why are they present in the same set when we use this operation? So why only two operations in a vector space? For that, the answer is, let me tell you the reasons. Okay, let us write the question first. First question is, so the first question is why only two operations? For that, let me explain. Vector space are designed to model linear system. So we must remember what vector space are designed to model of linear systems. Linear system. I assume you are aware what is a linear system. If not, then let me explain. For example, if you have an equation and it has variables, let us say x equals to y1 and y1, 5y1 and 2z. So this is kind of a linear equation because the variables z and y, how are they related to x or related to x? There is a proportional relationship. Also remember, linear systems, we can say kind of if one increases, the other increases in the same order. So if x increases 2 times, y may increase 5 times, and z increases 3 times. You must have another question. If it is x square equals to y, then is this x square equals to y? Then is this also a linear equation? This is not a linear equation because linear equation is always in the form a1 x1. However, your question must be, we know x square equals to y, the increase is fixed proportional. Proportional. Let me answer this. X square means if we increase x value, then it increases. Yeah, we can say it increases proportionally, but not in a mathematical sense, because it is not a direct proportionality. Also, linear system is taken from word linear, which means a line, straight line, specifically straight line. But x square equals to y, this would give us a graph that is not a straight line. Hence, this is not directly proportional. Intuitively, if you can say if x doubles, y doubles. If x halves, y halves. This relationship is straightforward and stays even like the speed and distance at a constant time. This is inherently linear, the origin when graphed. However, let us analyze y equals to x squared. So, first of all, I assume you must be pretty much clear about the previous thing I explained about the linear system. Y equals to x. Now, this is the thing that must be explained so as to remove the doubt from our mind. Y is equal to x multiplied by itself, or it is proportional to the square of x. So if you check y by x by adding different bits or checking with different values, this will not be a constant, not a constant. Intuitively, you can say if x doubles, then y quadruples. Y quadruples. And the scaling isn't even, it is accelerated. So graphically, it is a parabola. It is a parabola, not a straight line. However, just for clarification, in a broader sense, we can say y is proportionally related to x square. This is common in physics, like kinetic energy, because there we have learned these symbols. But it's quadratic proportionality, not linear proportionality. So there is a difference between linear and quadratic proportionality. I assume the doubt must be clear now. So, so we can proceed further now. Also remember, we can use addition and multiplication to stretch the vector in its vector space or to find the resultant because addition can help us find the parallel of its parallel or help us find the resultant. Similarly, multiplication can help us stretch or shrink it because we can use negative symbols. So these two operations are minimal set required to define the structure and behavior. Everything else is built on top of them. Also, they are in the same set, which was our second question. Because we saw that when we add or multiply it by a scalar, the result is a when we add two vectors or when we multiply a vector by scalar, the result is a vector in same set. This is because of closure property. Staying in the same set ensures that the space behaves predictably. No surprise, no escaping the rules. Now we are aware about addition and multiplication and why they are the minimum requirement for a vector space. We are also aware what is a vector. So the next question is this enough? No. Why? Because let us this operation needs to obey some rules or axioms that make the space consistent. We are trying to create a space. Imagine a space. Imagine vectors. You can imagine vectors anything. It can be a sound wave, a ripple flowing through the water. Okay. So we are trying to define it. And to define it, we need addition and subtraction. Not subtraction, addition and multiplication. But these two aren't enough to describe everything in the space. So what we do, we follow our rules of we follow rules for examples that makes this space consistent. So scalars comes from a field like a real number or complex number. Scalars come from a field. So you must be thinking what does it mean? Scalars comes from a field. Let me explain. So kind of you can think scalars are the numbers you multiply vectors by. So what are scalars? First of all, remember what we said. Scalars means to come from field. This word is very important. Field. So we will get to it. So we know what are scalars. Scalars are something that we multiply a vector by. If we have vector multiplied by a scalar. However, as we said previously, that we need to define it in a consistent way because if you want to do anything, manipulate the space, we need it to be consistent. So this scalar must behave consistently. Otherwise, scaling and combining vectors break the structure and we will not be able to achieve anything. Field. So This guarantees what? That scalar multiplication is well defined in so vector spaces will behave predictably with linear operations. Some examples of fields are real numbers, and C of X numbers, rational numbers, and three, five, nine, which are used in cryptography using also let us see what if we take an integer. Let us take an example that would not be considered as a field. For example, if you take integers, we all have integers are negative, means negative and positive. Numbers. Okay, whole numbers without decimals. So for this, we give you example. Look what happens. Every field above that we talked about, there is an inverse such that the number, whatever, whether it is a complex number, real number, okay, A into A inverse equals to this thing is satisfied. A, A inverse is to 1 is satisfied. Why is this needed? You must be thinking because only then division or also you must be saying division is anyway possible, but the condition is A inverse must now said of this in C. For integer, let us say if we have minus 1, we can multiply it by minus 1 equals to 1. So this is from set, minus 1 is from set, so this is satisfied. But what if I need to prove you would say 2 equal by 2 is to 1 by 1 by 2, not from set. Because that is whole numbers negative or positive minus 1, 0, plus 3. So therefore cannot the scalar that we use cannot be from integers. And the field theory that we finite field theory that we talked about. For now, let us just remember that this contains finite number of elements. Okay. So great. First of all, we define what is vector space. So imagine a space, close your eyes, you can put yourself inside a sphere. Now see that it sounds great, which others like ripples or waves affecting each other. Maybe they are shifting, they are parallel to each other, maybe their amplitude increases when they add up. Maybe when we stretch their wavelength decreases, frequency decreases, kind of. However, when you try to stretch the wavelength or shrink it or to keep parallel to each other, you must remember this is possible only because of addition and scalar multiplications. Then also remember with the use of these two operations can build another operation division and subtraction that is possible. For example, what you need for subtraction. If you have a number, just multiply it by minus. Also, we learned y equals to x square. It is a quadratic equation. Is it a linear equation or not? We found the reason because the increase is not proportional. And for linear systems, the increase is proportional. And why that's proportional? It's why we are talking specifically about proportional system that are linear because that are easy to predict. Okay, so we can use it for predicting many things. So then we check why scalar needs to conform a field because for consistency we need fields and fields must satisfy all the numbers inside it. Must satisfy numbers. So we have must have speakers same smell same like churches gives love and we then stop and visit with love because for there is such a between like this ones. This will not give us a partition space, a vector space where we can update the vectors or see the interaction with and education. So for this part, we are going to close it. But before we close it, let us try to make a graph or try to understand it into the views. So let us say I have a space. Okay, space that wavelengths data at whichever we can highly disturb. Maybe this leads to stretching. Maybe this leads to increasing amplitude. And these are predictable. Predictable. Why? Because whether we multiply these two or add these two with a scalar, and the scalar is always a field like scalar field, what is real numbers, complex numbers, maybe two, maybe these are the wavelengths. So 2 and 3, the scalars take here, and for them there lies a inverse value for 3 minus 3 which gives equals to 1. Hence, division is possible. So now next we will list those axioms that I talked about because in the early stages in the lecture I and addition and scalar multiplication, addition, scalar multiplication are needed, but these are not enough. We need some axioms. These axioms kind of we are trying to define or build something in reality based on these axioms that will help us solve real life problems. Okay, see you later.